Hi, in this video we're going to be talking about the concept of impedance. And that is because we have here in our RC circuit, we have here a capacitor, which is an element that stores energy. All elements that store energy have a property called impedance. Now, impedance is nothing else but a complex resistance. So we know that a resistance, for instance, resistance is the ability that the resistor has to oppose current. Well, impedance is essentially the same thing. The only difference is that the impedance is a complex number while the resistance is a real number. So an impedance represented by Z and also measured in ohms has got two parts. Has got a real part called the resistance, and let's represent that with X, and it's called an imaginary part, J for complex number, an imaginary part called the reactance. So a resistance is a purely real impedance, so the impedance of our resistor is simply R. Now, elements that store energy, like capacitors and inductors, in this case the capacitor stores voltage in the form of an electric field, have imaginary resistance, have what's called the reactance here. So the impedance of a capacitor is its reactance, which is 1 over J omega C, or minus J over omega C. Now note here that this omega in this circuit will be the same omega that we have in our input voltage. So for instance, if we have that our input voltage is A times sine of omega t, then we take this omega and we put it in here to calculate the impedance of my capacitor at that frequency. Now, we can also immediately see from here that for many frequencies, my capacitor will have different impedances. So that, for instance, when omega tends to 0, the impedance in the capacitor will be very big, will tend to infinity. And when omega tends to infinity, then the impedance of my capacitor will tend to 0. Now, in the last video, we talked about phasors and complex numbers, and this is exactly why the phasor representation is important, so that we can make calculations easier. And basically because once we start putting elements that store energy, we start having complex impedances all over the place. And it's very convenient to represent them in phasor form. So in this case, for instance, the impedance of the capacitor in phasor form would be the magnitude of this number, which is going to be 1 over omega c, with a phase, which is the inverse tangent of the imaginary over the real, which in this case we have the real part is 0, so it's the inverse tangent of infinity, which is 90 degrees, but we have a minus here, so it's minus 90 degrees. So basically it's the inverse tangent of minus infinity. So it's minus, I don't know why I can't write now, 90 degrees. So that would be our impedance of our capacitor in phasor form. On the next video, we're going to see an example of this circuit with some values here and there, and we're going to see how we're going to calculate how we're going to calculate the output voltage using all this knowledge. Thanks for watching.